So there are many manufacturers of radiosondes. Two of the more prolific ones are Vaisala and also Gras. Vaisala was created by a professor in Finland, whose last name was, of course, Vaisala. So it started back in 1936, and they manufactured radiosondes back then. They've been making radiosondes and other sensors for meteorological purposes since that period of time. They're worldwide. They have approximately 1,600 people around the world that manufacture, support, and sell meteorological instrumentation. And most of their instrumentation is used in other countries besides Finland. Here's the latest version of the Vaisala radiosonde. It's the RS92, and it gives you some values of accuracy, resolution, range, and also response time. And notice that the response times are less than 1 second, which is good because in 1 second you know that the radiosonde goes up about 5 meters. However, the moisture sensor is a little bit slower. Notice that it's about 20 seconds. There's a heating cycle. So that is probably the worst measurement that's made by the radiosonde, is the measurement of relative humidity. Here's a little bit of information about the telemetry and navigation system. It talks about how it needs 4 GPS signals to be able to triangulate its location, and also talks about its frequencies, and also the data cycle being one measurement or one transmission every second. Then the winds, there measures the wind accuracy of 0.2 meters per second, which is about a half a knot, which is great accuracy. And the position accuracy, both vertical and also horizontal. Vertical resolution is actually rather good. Gras is another company. They started making radiosonde equipment in Germany in 1939, and they have also people that purchase their and use their equipment around the world. Here's a picture of the one that we have at the University of North Dakota. We have a ground station and also Gras software, and then all the other things, including the radiosonde, the unwinders, the balloons, and helium. If it's very low weight, 90 grams, and they're ready to fly, the instrument package is made of styrofoam. You can see that the thermistor and the hygristor actually pop out. They use a lithium battery, high power lithium battery, and also GPS. The Gras has an unshielded temperature sensor and also a relative humidity sensor. Pressure comes from GPS, surface pressure, and the hydrostatic relationship, so there is no pressure sensor on board this device. Here's some more information about the radiosonde, and we'll move on to Dropsondes. Dropsondes basically are more or less the reverse of a radiosonde. A radiosonde goes up, Dropsondes come down. So these are expendable packages, instrument packages once again, and these are released from aircraft. And as they descend through the atmosphere, they measure pressure, temperature, relative humidity, and also can calculate wind based on GPS position from successive reports. So the Dropsonde is very comparable to a Raywin sonde, just in the reverse direction. The Dropsonde is usually, of course, dropped from an aircraft. There is also receiving equipment on the aircraft, so the information is transmitted via, of course, telemetry to the aircraft, the equipment in the aircraft that can receive that, and then it's processed in the aircraft. Dropsondes were created by NCAR, and they were designed specifically for tropical storms. So dropsondes are only deployed over oceans. They are not dropped over land, and they help improve forecasts of hurricanes and tropical storms. Here's more information, more technical information. It shows the sensor, the both the temperature sensor, humidity sensor, and also there's a pressure sensor. These dropsondes drop a little bit faster than the radiosondes going up. They come down at anywhere between 11 to 20 meters per second. They have a parachute, and the parachute is designed to slow its descent. Here's more information. The dropsondes are made by Vaisala, and there's the mass of the package and more information about the deployable airspeed and the telemetry range. Here's more information about the sensors themselves. Looks like the barometer uses a silicon, an aneroid silicon. Also, the thermistor is platinum resistance. It's got heated capacitance high gristors, and typically takes about 15 minutes to launch, or the 15 minutes for it to obtain information from 14 kilometers as it descends down through the atmosphere. If you want more information about dropsondes, here is a YouTube link and you can watch that. So I hope you enjoyed this video on radiosondes and dropsondes.